Alright, so we've previously looked at how to factor the difference of perfect squares, but now we're going to look at factoring the sum and difference of perfect cubes. So we're going to talk about what a cube is again, just to kind of refresh our memory, and then I'm going to show you the formula, I guess you could say, for the sum and difference of perfect cubes. So what exactly is a perfect cube? It's something I'm sure you've heard of before, but just to refresh our memory. Well, remember when we're talking about perfect square, it's something that can be written as something squared. Like 4 is a perfect square because that's 2 squared. 16 is a perfect square because that's 4 squared. Okay, so perfect cubes are numbers that can be written as something cubed. Okay, so for example, 27 is a perfect cube because it can be written as 3 cubed, or 3 times 3 times 3. 64 is a perfect cube because it can be written as 4 cubed. So here on the side, I've listed a few of the, the first 10 perfect cubes, just so we can kind of recognize them whenever we're doing problems. Alright, so here it is. Here is the formula for the sum and the difference of perfect cubes. So remember, when we had difference of perfect squares, we only were allowed to have the difference of a perfect square. Remember, that was a huge deal. It had to be a minus sign. Well, just to, completely mess you up, for cubes, you can have a plus or a minus. All right, so it works both ways, but things are a little bit different for each case. All right, so here's the formula. When it's sum, so perfect cube plus perfect cube, it breaks down into a small binomial and a trinomial. Okay, small parenthesis, big parenthesis. Now, within the small parenthesis, we take the cube root of the first number plus the cube root of the second number, and this is going to be a plus sign. Now, where do you think this plus sign comes from? Well, it's a plus here because it's a plus here. All right. And then in our trinomial, we square whatever that cube root was, minus these two multiplied together, plus the square of the cube root of the second term. Okay. It's going to sound like a lot to remember at first, but really it gets easier. So I want you to notice something. Whenever we do the difference of two cubes, same exact process, okay? It's exactly the same, except for this sign right here is going to change whenever this sign changes. So remember, these always match, and then these guys are always opposite, okay? So if you start out with the difference of perfect cubes, your first binomial is going to have a minus sign. Therefore, your next sign inside your trinomial is going to be a plus. Okay? With sum, if it's a plus, then the first binomial is a plus, and then the first sign in your trinomial is a minus. Okay? Hope I haven't lost you just yet. Now, notice that this back sign is always a plus sign. Always, 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 always. Okay, remember that's because when you're squaring something up here, when you're squaring, you always are going to get a positive number. Alright, so these are formulas. Yes, you just need to memorize them. It's just something that you need to get used to. And I promise once you memorize these quick, easy formulas, you'll be able to do these easy peasy. Alright, so here, first we have to check, is this a perfect cube? Is it a perfect cube? In this case, yes, both of them are perfect cubes. So they fall under this formula. So cube root of x cubed is x. So here I'm just going to write this. You don't always have to write this, just to help when you're first learning. A is going to be x. And what is the cube root of 8? Well, the cube root of 8 is 2. So b is going to be 2. And now we're just plugging into the formula. So I have x plus 2 times x squared. Now a times b, so that's minus 2x plus, and then I have to do b squared, so that's going to be 2 squared, which is 4. Okay, let's just double check. These guys need to be opposite signs, so plus minus. This is a plus because I started out with a plus here. And then this is the square of this is the square of this, and this is these two multiplied together. So hooray, that's it. I am done. Alright, so here we go. Well, let's double check. 16y cubed. Well, y cubed is a perfect cube. Is 16 a perfect cube? Is there a number times itself 3 times that gives me 16? Nope. What about 54? Let me think. Nope. All right, so now I have to recall on my previous knowledge about factoring, which is that you always, always, always look for a, wait for it, GCF, right? So I'm going to factor out a 2. Factoring out a 2, I'm left with 8y cubed plus 27z to the third. See what I did there? See what I did there? All right, so now 8's a perfect cube, y cube's a perfect cube, 27's a perfect cube, z cube's a perfect cube. So now I'm all ready to go. Now, what is a going to be? Well, what is the cube root of 8? It's 2. What is the cube root of y cubed? It's y. What is b going to be? What is the cube root of 27? That's 3. What's the cube root of z cubed? Well, that's z. So now it's just plugging into the formula. Do not forget about your 2 that's hanging out front. Okay, he's part of my answer. So small parenthesis, big parenthesis. Right? So my cube roots go there and there. 2y. This guy's a plus, so this guy's a plus, plus 3z. All right. Now, okay, this is the tricky part. I need a squared. This is where everyone's going to mess up, right? So I need a squared. Well, a was 2y. So what is 2y squared? If you forget your exponent rules, that it distributes to both, and you know that it's 4y squared, just remember that's 2y times 2y, right? Which gives us 4y squared. So I get a 4y squared here. These guys are always opposites, so it's going to be minus. Now I need to take these two and multiply them together, so I get a 6yz. And then this back term's always positive. And now I need to take 3z and square it. Okay, be careful, right? 3z quantities squared is going to give me 9z squared. And then that's it. Don't forget the 2 out front. And if you really wanted, which you should all the time, go ahead and multiply it back, and I promise you you'll get what you started with. Alrighty, so what about when there's a minus here? Okay, remember the only thing that's going to change is that the first parenthesis is going to be a minus. The second parenthesis, the first term will be a plus now because these are opposite signs. So x cubed is a perfect cube, 27 is a perfect cube, so I'm ready to go. A is going to be x, B is going to be trace. Alright, here we go. So it's going to be x minus 3. And then I'm going to have x squared because I square a plus, remember because these guys are opposite signs, right? Plus my a times b, so 3x. Okay, I want you to notice I didn't do negative 3 times x because b is not negative 3, b is 3. This negative here is because this negative here, so you don't bring the sign with it, okay? So 3 times x gives me 3x. And then my last term here is going to be b squared, so that's 3 squared, which is 9. And that's it. Multiply it all out to make sure you did it right. Alrighty, one more example. So 24, perfect cube, something times itself 3 times, give me 24. Not quite. X cubed is a perfect cube. 3 is not a perfect cube. So maybe I should look for a GCF. Wow, who would have ever thought that? So factoring out a 3, I'm left with 8x cubed minus 1. Wow, so 8, is 8 a perfect cube? Sure is. Is 1 a perfect cube? Sure is. 1 times 1 times 1. So my a is going to be the cube root of 8. Cube root of 8, right? So that's 2. B is going to be the cube root of, A is 2x, my bad. And B is going to be just 1. So plugging this in, Don't forget about the 3 hanging out front. That's going to leave me with 2x minus 1 in my small parenthesis, my binomial. Now I need to square 2x. So again, tricky part, right? Squaring this, that gives me 4x squared. Now I want different signs. I need to multiply these guys together, excluding the sign. And then I want to square my b, which is just 1, so I'm just going to get 1. So there we go, fantastique. I am done. Now, for those that are curious, I'm sure you're wondering, I'm sure everyone is wondering, does this trinomial right here factor any more? Okay, can I factor this any further? All right, this right here, a squared plus ab plus b squared. Will this ever factor to be, broken down into 2 more binomials? Well, I want you to think about that. All right, so think about that, and then we will talk about that in class. All right, guys, now give these a try.